This video is part of CAE Associates ANSYS e-learning series. CAE Associates is an engineering consulting firm in Middlebury, Connecticut, specializing in finite element analysis and computational fluid dynamics. We have been an ANSYS channel partner since 1985 and have developed our ANSYS e-learning series to help you maximize your software investment. Please visit our website, which includes an extensive resource library with over 250 items and counting in an easily searchable area. We also invite you to visit our Engineering Advantage blog, where we share insights from our many years of performing engineering analysis. CAE Associates also offers an extensive schedule of ANSYS courses taught at our Middlebury office. If you need help deciding on the best courses to take for your application, visit our CAE University page. The complete library of e-learning recordings is available for viewing in our resource library and also on our YouTube channel at youtube.com/CAEAI.
So, talking about ACT, what is it? Well, other than it's called Application Customization Toolkit, but it's really just a new capability that came out in Workbench that allows you to build in your own features into the mechanical interface. So it allows you to customize that interface for your specific need. And those things could be, in terms of customization, really it's set up for pre- and post-processing. I'll say it's probably the main use, but those pre-processing customizations could be something like you have your own unique load, boundary condition, something like that that you want to put into mechanical interface that's not already there. So ACT allows you to do things like that. So maybe you also want to just change an element key option or some solution setting or some minor setting that you know is in Classic and it's not in Workbench GUI. So ACT will again allow you to do things like this. And you could also have your own unique post-processing result item that shows up. So that's really the main focus, I would say, but you could also use ACT for accessing information in the mechanical interface, say node element numbers, access geometry, and different finite element information that you otherwise wouldn't be able to get to. And of course, you can also use ACT to tie Workbench mechanical into a different solver. So those are really the uses for ACT. At this point, ACT is a new utility that is only going to grow and expand upon, but that's really where it is right now. So ACT really provides you the hooks that are already in the code to be able to link in what you would like to add into the code. So you don't need to compile anything or use existing libraries. You can just basically attach your customization to what's already in mechanical. So if we looked at just all this stuff, what we're talking about here is that ACT puts in these customizations, right? So you see all these buttons that are across the top toolbar here. These are all ACT extensions in there. So these function just like any other capability that's already in mechanical. So it will look like that. And what can this do? Well, really, it's ACT is set up to allow you to put in something specific that you need into the code, right? So ANSYS is just a general purpose code, so it works for a wide class of problems, but it may not have your specific load or might have something very specific to what you do. And you know that that's something that's available in Classic, and you just want to use that capability in mechanical. So it allows you to do that. And this is really set up to kind of get rid of the need for command blocks. So then instead of using a command block, you can build in your own button, and it does exactly what that command block would do. So this makes it easy to roll out this extension to the whole company. Everyone's doing the same exact thing. They don't, no one else has to, develop or type their own command block in. It's just basically additional functionality that's already there once it's set up. So ACT, though, I'll say, is really not a tool for scripting already existing features in mechanical. So you insert, fix support boundary condition. That's something that's already in the GUI. ACT is not really set up to automate that type of a task. It's really more set up for you want some new features in mechanical. So just a little rundown on that. So now that you kind of know what ACT is and at least what you can do with it, let's just take a quick poll here. You should see the poll pop up on your screen. So what would be your main use for ACT? Now knowing what it can be used for. So if you go ahead and submit your answers. So what would be your main use for ACT? And it looks like mainly either reusing APDL macros or a new load or boundary condition. And I'll say really the way that is set up with ACT is really they're sort of the same. You're essentially replacing either an APDL script or your new load or boundary condition would be some type of APDL. So they're really kind of the same in terms of what would be required from you to do that, but again, different uses. So that's certainly a majority result quantity. So okay, so that's good. No one wants to at least link to another solver. That is another capability. Great, thanks for participating in that. So we'll you can close that polling window if you'd like. So now I already showed what the ACT extensions look like when they're installed. And they just show up as buttons on the toolbar. They could also be menus in the GUI. However you want to put that in, you can do either. But once that extension's installed, then you click on that button, and then that new feature gets inserted into the outline tree right here. So we see something called wind load on surface in this case. And then you can highlight on that object just as if it was an already existing object in mechanical. Go down to the details pane. So you select some surfaces for this object, and there's also some different inputs that this will take. So everything looks exactly the same as, say, this fixed support boundary condition, right? You insert it the same way, you do the same thing. So it functions just like any other feature. So then how do you go about setting this up or creating your own extension? Well, everything that you see in the GUI, right here, the button, the icon that's attached to that, where this shows up in the outline tree and all the details that correspond to this, that's all set up through an XML file. ANSYS does have a bunch of examples already out there that you can use to basically modify for your own purpose. So you don't have to really reinvent the wheel, but you need to set up an XML file that's going to control what it looks like in the GUI. And that XML file handles the data that's inserted in to the details. So then there's also a Python script that you'll need too. So that way when you click the button, or really, if we think about what we need to do here, this is an object that's in the outline tree, and we put some data in here. But this doesn't really mean anything because this is something in the GUI. We really need to get this into ANSYS Classic, right? Just as a fixed support boundary condition, you hit the solve button, that fixed support gets written out into the ds.dat file when you hit solve. So that's a process that goes on when you do that. So we need to do the same thing with this wind load that we put on here. We need to take this input data that we're providing mechanical and then feed that into the ds.dat file when we hit the solve. So that's what the Python script does. There's way to and examples for this, for how to link that in. But when you hit solve, then it takes all these inputs, basically grabs the faces, maybe creates a component from those, sets up some elements, options, or surface pressure in this case based on all these different values. So that's what we're doing. We're putting something into the GUI, but really at the end of the day, it gets written to the ds.dat file, or the ANSYS Classic input file. So that's what's required to create an extension. Now, once you have your extension, you are, well, it's just a file. WBEX is the extension for it. But that is a compiled version of the XML and Python code. So that's something that a user that's creating the extension will do. They'll compile it, so then they can give this file to anyone in the organization to use. So then all the user would have to do is go on the project page, extension, install the extension, and then they choose to manage the extensions afterwards. Then it'll pop up a little GUI on the project page that says, what extensions do you want to use? And then once you check the one you want to use, when you open up Mechanical, that functionality will be there that's related to that ACT extension. Now, there's no licensing or anything required for that. Once you have that extension, compiled version of it, anyone can use it. There's no licensing or anything required for that. There is a license required to build the extension, though, or essentially a license to compile the code, the XML and Python. Because once it's compiled, you can give it to anyone, and there's no license required. So really the license is for you to create that file to give to other people. And then as a part of that, you also get technical support for ACT, and you get the documentation, the developer's guide, and the API guide for how to create your own extension. So that's in terms of how it's licensed and set up. So if you look at what you have access to right now, anyone that can get onto the ANSYS customer portal can download all these different ACT extensions, and you can try them out for yourself right now. So just some of the different ones that are already up there, you can create some, say you can run acoustics in mechanical, so that's a pretty powerful one. There's piezoelectric capabilities. Actually, the Workbench Elastine extension might be the most extensive extension out there. It lets you set up, solve, and post-process the Elastine simulation, which is different than the Elastine export, which just writes out the .k file. This you can actually do some more things and read in the results in there. But there's some other ones, FE info, change materials, do some 2D morphing of nodes and submodeling. So there's a bunch of ones already up there, and hopefully they'll just continue to grow in the future as more people submit extensions to that. Some extensions that are not up there, but they're ones that ANSYS has developed. This one allows you to do component mode synthesis in mechanical. So you can create super elements from different bodies, and then behind the scenes it does a generation, use, and expansion path for those super elements. So this is a rather involved extension, call it a premium extension, but this was one that was developed for a particular customer. Another example of this type of extension that was developed for a customer was an assembly manager. I'm just showing these so you can get an idea of different things that can be done with this type of customization. So say you had some small component on the top right here. You wanted to analyze this thing, but then you wanted to also include in some other parts that would make up the full assembly. So you build in a separate mechanical simulation. This part, you mesh it, you have all the materials, you have all the contacts, everything's set up in this project. Maybe this was even solved, but everything was all set up in here. You can use this Assembly Manager extension to save or write out this mechanical simulation of just this part. And then you can choose to then import that that mechanical simulation into your existing project in here. So all the mesh, contacts, material properties, loads, everything that used to be in this standalone simulation is now added to the existing project. And then you could also add, some other, maybe it's the same component and you just put it in a different location, whatever the case is. So this is combining different mechanical databases all in one. So that's a nice, very powerful one. But again, that was something that was developed by ANSYS for a particular customer. So just quickly, if you do have any ACT extensions that you think you'd like to develop, or you just have questions about, whatever it is, we've developed extensions here. So we have expertise with that. If you want to discuss any questions or opportunities you have for creating an extension, please feel free to contact us, and then we can help you out, or at least have some discussions about what you want to do. So let's take another quick poll. It looks like, it's kind of split. Maybe you're unsure if that would help or not. Fair enough. And some, I think that it would help to get more users to using Workbench. That's great. If that's the case, like I said, ACT can certainly help bridge the gap between the functionality that you'd like to have in there versus what's actually already in there. So now let's see some of these different extensions in action. That WinLoad example that I saw or showed you is really doing this behind the scenes. Or let's say this example, a customer wants to always apply some type of win loading based on some standard that they have. right? They're always doing this. This is something that's not already existing in the code, and it would be nice to always have this feature available. So you can make an extension to do this. And behind that extension, you have a bunch of different constants and equations that come up with the resulting wind load that gets applied to the model. So also prone to errors, maybe, getting all this stuff right. So I certainly don't want all the users to be able to do this every time they need this. So you can create your own ACT extension to do this. In this case, it's the wind load that shows up here. So when I click this button, it inserts it into the outline tree. So when we highlight on this, we need to fill in some data, no different than any other object in mechanical. So we apply that wind loading to a bunch of the faces. And in here, one of the nice things is that you can see units are associated with these different inputs. Right? This is not something that is associated with a command block. You could certainly do this with a command block, but if you went and changed the units to a different system and then solve that, the command block no longer matches up. So this keeps track of all that. It'll do the conversion for you. You can put little drop downs in here, whatever you need to do for that boundary condition. And then we can go and solve the model. So we already have some results in there, and then you could see the result of that wind load in terms of just looking at the deformation that's on here. So you can see that makes it very easy to build in some functionality that wasn't there previously. So that's one example. Another example of an extension is right here, where this is a nonlinear analysis that was run. It squishes this down. You have some time history down here. So there are some results already available in terms of grabbing out contact status, pressure. You can get some things in here initially. But what if you wanted to get, say, what was the contact stiffness through all of those different iterations that went on through here? Well, that's not something you could pull out here without beta options or something. So you can create an extension to do that. Another one here is nonlinear info. Insert this into the tree, and this is a post-processing object. So in here, we can choose which contact we want to get some information from. So this will be that contact pair in there. And then we can do that one. Say, what's the normal stiffness, maximum normal stiffness for all those different iterations. And then down here, this charts it up. You can see all the different sub-steps and then the normal stiffness here. So once the part comes in contact, you can see the stiffness associated with that and how it changes through that. And maybe, I don't know, you put in number of elements that are in contact in the normal direction. So you can see here, that's the number of elements. So then at the end, we get about 5 elements in contact there. So you can track up a bunch of different information in here that might be a little bit more difficult to get out or maybe isn't available at all. So that is another example. It happens to be a post-processing one. Another one is this FE info example, where this is accessing information in the GUI. So let's say we wanted to select some elements. Well, that's something you can do in here. You can select nodes, make components of those, but maybe we wanted to find out where elements, let's say 1 through 20, are in the model. So we can, oops, where'd it go? Okay. Goes in here. Oh, no. Zoom in here. You can see that it plots up the elements in here, colors them, so the element numbers, and we also have the nodes numbers showing up in here. So you can plot elements, you can query node numbers, and there's a bunch of different things that is available in here. That makes it nice and easy. Say your solution failed to converge because of some element distorted. Well, then you can look up where that element's located in the model. So, again, that's something that's available for GUI manipulation or accessing information out of the mechanical GUI. Let's look at another example. Let's say that we ran this 2D thermal analysis. So we have some temperature distribution on this model. And then we want to take this temperature distribution and map it onto a 3D model. And so then if we go in here, build a 3D model. Hello. There we go. So we have this 3D model that we want to apply that 2D temperature distribution on. So then we can do that with this submodeling extension here. There's one for temperature, one for displacements. So if you insert this temperature ACT extension, then when we highlight that, we select the bodies that we want to apply this temperature mapping to. We need to give it the file, the result file, from that 2D analysis, and say that the submodeling is going to be from 2D to 3D. And then there's also some tabular information here. So there's 2 load steps in this structural problem. What temperature results we want to map in from the thermal result file? So you can see you can pop up little tables, different things like that, little drop downs. You know, there's a lot of things you can do with the extension. So then we can go and solve this analysis with the structural loads, but then we put on a user-defined result item for the temperatures and see what the temperature looked like. So it took the 2D temperature and then just, you know, mapped it around the circumference here. It might look a little different if this was actually a 3D thermal analysis, but, you know, it gets you maybe a quick approximation to what that might be. So then let's say we also looked at stress. We find the stress in this hole at some value. And see that this is a fairly coarse mesh around there. So maybe we want to, without having to rerun this entire model, just submodel this local region in here. So then we can do that and use the submodeling extension for displacement. So we build a model of just this localized region. We have a much more refined mesh on here where we, you know, have some more elements near the surface. And then we apply this submodeling for displacement, degree of freedom mapping, and then they click the 2 faces here. That's going to get that mapping 3D to 3D. It could also be 2D to 3D, 3D to 3D, cell to solid. There's a bunch of different options for that, but this will map the displacements from that previous structural analysis of the result file onto here. And then maybe we also just grab the temperatures, too, that were in that last example I showed, the 3D temperature distribution, 3D to 3D. Or this could have been 2D to 3D from that original model too, whatever you'd like to do. And then you run this analysis and see that you have a much higher stress at this location. So, you know, just illustrating that this submodeling technique can be done with an ACT extension. That certainly isn't the only way that it can be done, but it certainly makes it nice so everyone that's using this extension can just, you know, have that option in the outline tree. So it makes it very easy for users to be able to, you know, essentially seamlessly add in some additional capability. So let's go back here. That is it for the presentation.